Sure. Okay, you guys ready? Last section. If we have time, we can maybe do some on the practice test. Did everybody get a practice test, a theorem sheet, and section 7.6? Okay, so these are your last sets of formulas. We won't be doing section, I know it says 9.3. That was just like the old section in another book. We're not going to be doing 7.7 because it's optional. There's no problems in my math lab anyway. I was going to introduce it, and sometimes I do, but you don't really need it. That's why it's optional. They say we can teach it if we want or not, because you don't really use it in the next class much. But you definitely need half angle, double angle. Okay, so this is all of this is about how to do evaluate double angles and how to evaluate half formulas for each one. When there's multiple formulas for the same thing, just memorize the one that you think is going to work best for you. Like a lot of people for this double angle cosine, you see that there's this one, and this one. You can memorize any of them. A lot of people memorize this one because it seems like familiar to them because of Pythagorean. So one of those three, memorize it. So you'll be able to do a double angle for cosine. This is the only one for sine. This is the only one for double angle tangent. So they're going to prompt you like that in the question. They're going to say, find the double angle, you swing into that formula. If it says do cosine double angle, you can use that, or that one. And for sine of a double angle, so you see, that's why I was telling you start getting ready last week, because you got a lot of formulas to memorize, and you can't stuff that in. Put a bunch of attention into today and tomorrow, trying to make some note cards, because you're getting these at the last minute, and the test is on Thursday. So you got to start working on those. Half angle, these are the half angle formulas. Somebody asks you to find half of an angle. Everything, again, is going to be related to 30, 60, or 45. Somehow you're going to relate to those things because you're going to be expected to give exact answers, not decimals. These are all the half angle formulas. For tan, you see there's three of them. Use the one that you want. You're probably going to choose, if you have a choice, not to use the one with the radical. So it's up to you which one you want to use. Okay, here we go. You can be looking at the sheet as I show you how to use them. All right, now some of these first questions at the beginning, like let's see, this one probably just wants the formula. Okay, expression that completes, half angle formula for cosine, all they're asking for is the formula. You could get that right off of your sheet. So if you're looking at the half angular formulas right there, it is a fraction, and at the top of the fraction it's 1 plus cosine of the actual angle that they're asking you to cut in half, but without cutting it in half, and then the 2 from the half goes down here, and all of this is underneath the square root. Right off your formula sheet, you're not calculating anything there. They just wanted you to reiterate the formula. Stop me at any moment that I start doing an actual problem and you don't understand it. Hey, going to this one, now you're calculating things. Okay, so they're giving you information to go and build the answers yourself. Let me focus this. Okay, so first thing that we're going to do is we're going to go in between 0 and pi over 2 and build this triangle. Okay, so this is 0, this is pi over 2. We're going to spin between 0 and pi over 2. Here's my spinning arm. It represents the hypotenuse. Drop to the nearest x-axis. Put these numbers on the triangle. So let's see. Sine is y over r. So this represents the y. This represents the r. And then you should go and get the piece that's missing. Let me make this smaller. All right, so Pythagorean theorem. It's going to be hypotenuse squared. Let me move this down a little bit. Going to be hypotenuse squared is equal to legs squared. This is the one that's unknown, the x, plus x squared. So this will be 64, this will be 25, this will be the x squared. Okay, bring the 25 to the other side. So 41 for x squared. And then x is equal to square root of 41. Take the square root to make that square go away, likewise on the other side. Okay, so this turns out to be, oh, you got 39? Okay, sorry. I subtracted. So this ends up being square root of 39. Thank you. Okay, then let's go get the formula so that we can do the things that we need to do. So for part A, you're being asked to do the sine of a double angle. Look on your formula sheet to go get the formula for doing what I'm about to do, which goes like this. 2 times sine of the regular angle theta times cosine theta. So I got that off your formula sheet, and now go plug in. Your picture is built off of just theta. To actually get this formula to give you a double angle, a 2 theta answer, you have to use this formula. So it allows you to use a single theta type picture to get this kind of answer. So now it's off the picture. Sine of theta is the value they gave you, 5/8. Cosine, and you can maybe write these definitions as you go along because this is the stuff from Chapter 6. It appeared in Chapter 7 as well. Sine is y over r. They gave us that, though, to start the problem. Cosine is x over r, so that square root of 39 is what we needed, is why we needed the square root of 39, why we needed to do Pythagorean theorem, r 8. And then multiply. There's a lot of algebra in this section, a lot of like simplifying radicals and stuff. Okay, so as you multiply here, you can reduce right now or you can reduce at the end. This 2 belongs to the top, so it's 2 times 5, 10. With the square root of 39 hanging off the back. There is a 64 on the bottom, and then if you can reduce further using the numbers that are on the outside of the radical, do that. So 2 goes into the top 5 times. 2 goes into the bottom, divides into the bottom 32 times, so your final answer, 5 square roots of 39 over 32. Okay, that's part A. Part B. Pick one of the, but I guess you're going to want to pick the one I'm picking, just so you can follow me, but I typically use this one, not that the other ones aren't just as good. There's 3 different formulas for cosine of a double angle. I'm going to use that one, just because that's the one I just happen to remember the best. Okay, so what this says is take your cosine, square it, then take your sine, square it. Okay, you're getting those things right off of the picture. Okay, sine is the y over r value, so 5/8. Or no, wait, cosine first, sorry. So cosine first is square root of 39, the x over the r. The sine value, which we're going to put right in there, is the one they gave us, which was 5/8, but you can also see it on the picture. Okay, then square the top as well as the bottom. So when you square the top, you get 39. When you square the bottom, you get 64. Don't forget to do that here as well as here. Square the top, square the bottom. Okay, when you subtract, you get 1. Then you get 14 over 64, and then you can reduce it to 7/32. So that's the answer for B. This is the answer for A. Is anybody checking the answers as we go along? That saves me not having to flip back and forth. So let me know anything goes crazy here. Okay, part C. Now we got to do some choosing, because in this formula there's a plus or minus, so I want to show you how to pick the plus versus the minus. Okay, see these formulas right here? We're about to do sine of half of an angle. You see how there's a plus or minus there? That plus or minus is not like the plus or minus in quadratic formula. You know how that plus or minus actually makes you give both answers? Well, here you have to pick one of them. And so the way you're going to pick it is based on the angle. So I'm going to show you that first, and then we'll go on with the problem. These are going to be a little bit messy. You're going to have very often a radical underneath another radical. Don't worry about that. That's typical when you're doing half angles. Sometimes they're like that. Sometimes, it depends whether you're starting with radicals. But anyway, okay, so let's write the formula. Sine of any angle cut in half is equal to, we have to choose one of these. And then there's all this stuff underneath the radical. There is 1 minus the cosine of the angle that you're cutting in half. And then the half is now down there in the denominator. Okay, so to choose. Now they said that in the beginning of the problem, let me point to it. See how in the beginning of the problem it said theta was between 0 and pi over 2? Let's grab that. Write it right here. Theta is between 0 and pi over 2, said the original stipulations. But then aren't we now taking the theta and cutting it in half? So now come in here. Cut this in half, and if you're going to cut this quantity in the middle in half, then you have to cut this in half also. Cutting in half means dividing by 2. I'm going to write it like that right there, but here I'll write it like that. Just you're dividing everything by 2, just so you can create a half angle in the middle. So what does that turn these endpoints divided by 2 is 0? Leave your half angle written as a half angle. And then you know how to do this, that when you're trying to divide by 2 and it comes to fractions, you leave the number in front of the division sign alone. You turn the division sign into a multiplication sign and you flip that over, multiplying by the reciprocal. So now, when we start to do the portion of the problem that addresses a half angle, we have to think about, in order to pick the plus or the minus, what kind of sign, I'm going to have to say the word sign twice, I'll say it a different way. Is the sign value, positive or negative if you're in between, I just got my calculator to cover it up, if you're in between 0 and pi over 4, aren't you in quad 1? Yeah, so if you're in quad 1, is the sign positive or negative? Okay, so because the theta over is before pi over is, it's less than pi over, it's between 0 and pi over 4, that would put you in here somewhere. And then the sign value is positive in that case. Okay, so we're going to pick this one. Okay, here we go, plugging in. All right, so it's 1 minus the cosine. The cosine is off of the picture. We've used it in parts A and B already, square root of 39. So you got a double radical here. Square root of 39 over 8. Bless you, over 2. Okay, now comes, the nitpicky type stuff, trying to bring those two pieces together, make them both an 8. You want both of those an 8 so that you can draw them together into one fraction. So here we go. See that 1 right there? Let's call it 8 over 8. Now let's bring them together into one fraction. I'm going to come down here. So it's 8 minus the square root of 39 over 8, but yet again divided by 2. Okay, now remember, we're taking one fraction and we're dividing it by another. So that's really, when you're doing division with fractions, you're really going to multiply by the reciprocal. Okay, here's your divisor, right? It's a 2. You're really going to multiply by 1/2. Float and flip to do that. We can rise this right up here and treat it as multiplication rather than division, but using the reciprocal. So there I just floated this number to the top. I wrote the reciprocal of it, and now I want to forget about it down there. So coming over here, let me get rid of this creepy little picture and put my answer. Okay, so now we're down to this. All underneath one radical, we have 8 minus square root of 39, and then the denominator would be 8 times 2, 16. Okay, now which piece of that, the numerator or the denominator, can I actually take a square root of, and therefore I can remove it from underneath the radical? The top or the bottom, can I take a square root of? Bottom, right? You can take a square root of 16. So out comes the 4, and inside is going to stay the 8 and the negative square root of 39. Now, do you see how this 16 is in the bottom? It comes out in the bottom, not as a 4, as a 1/4. So answer here, 1/4. That has to do with this guy right here. And then this radical is going to now only contain 8 minus square root of 39. Somebody check the answer, please. Are we good? Is it positive? They picked the positive one? Yeah. Okay, good. Perfect. Let's move on. Cosine of theta of a half angle. Okay, now I've run out of room, so let me move to paper. So now I'm on part D. That part was we're trying to do cosine of theta over 2. Let's go grab the formula from the formula sheet. There's only one formula there, but again, it does have a plus or minus. So when you're doing sine of a half angle, it's got a minus there. And when you're doing cosine of a half angle, it's got a plus there. Okay, so let's go ahead and plug into all of that. All right, again, you just know I went through that whole spiel, right, where I took the theta and I cut it in half, and it turned these two endpoints into 0 and pi over 4, right? We talked about how that means you're in quadrant 1. Isn't sine and cosine both positive if you're, like right around pi over 4? So we're going to pick this again, and let's start plugging in. The only difference is going to be the plus sign there, so it's 8 over 8 for the 1. For that 1, I'm just rewriting it as 8 over 8 because I already know cosine is going to have a denominator of 8. The cosine is what? Off that picture, square root of 39 over 8. The only difference is the last. I mean, you don't have to do it all over again. I'm just giving you the work. Anyway, all of this turns into 8 plus square root of 39. I already went through most of this. You end up with a 16 on the bottom. That's after you pull these together and float and flip. All of that going on here. And I don't care if you just jump right into the answer. So 8 minus square root of 39 or plus square root of 39. So like when you get to the test, the only thing is if I make you do half an angle for sine, I'm not going to make you do also half an angle for cosine. So you won't be able to feed off the other answer. But you know the only difference for this could have possibly been that this one has a plus, the other one had a minus. This is the same answer as the one we got in part C, only there's a plus here. Okay, finally, moving on to number 3. Okay, so here we go with tan. Can I stop and ask anything about anything that just happened there? Oh, everybody's good? Semi-good? Okay, so let's see. Number 5 starts off with, maybe I will have some room to do it here. Okay, so my picture. Let's get a picture here. It says that tan of theta is 5/4. We should be between pi and 3 pi over 2. All right, so let's see. Pi. Here's 3 pi over 2. I'm supposed to, my rotating arm in theta is supposed to be in between. I'll just call that theta. All right, let's put these numbers on the triangle. So to know where to put the 5 and the 4, you have to know the definition of tan. It's y over x. Therefore, the 5 represents the y. The 4 represents the x. Now, in the quadrant that I'm in, aren't the x values and y values both negative? So toss a negative there and there. We can go ahead and do the hypotenuse. So we'll call the hypotenuse r. It's going to be r squared is equal to leg squared plus leg squared. So this is going to be 25 plus 16. So r squared is equal to 41. And then take the square root and you get r is equal to square root of 41. The r can't ever be negative, but the legs can, depending on what quadrant you're in. All right, so we got all that. Now let's start answering the questions. Okay, I think I could do the work for maybe one of them or two of them here. Okay, so here's part A. So sine, that's kind of like the easiest one to remember because it's so simple. I would try to concentrate mostly on getting in your head the half-angle formulas because you're going to find the double angle ones easier to remember. So this is just 2. It's like the 2 comes out there, and it's like sine of theta times cosine theta. When you're doing these problems on the homework, write the formula every time so you can be practicing memorizing them. Okay, so coming over here to do my work off of that side, off of that formula right there. 2 cosine sine. Okay, so cosine was x over r, negative 4 over square root of 41. And then it doesn't matter which one I put first, but yes, I should have put that one there and that one there. You're going to get the same answer either way. So I just did cosine. I put that one first. Sorry about that. And then we'll just put the sine here because you're multiplying them, so it doesn't matter which one you write first. Okay, so sine was negative 5 over square root of 41. So negative 5 over square root of 41. And now multiply them together. Okay, remember the 2's at the top. When there's a number off to the side, it really belongs to the top. Multiplying off the tops, as you always do when you're multiplying fractions. So you have 8. And then 8 times negative 5, this is a negative times a negative, 40. And then on the bottom, 41. Okay, so 2 times 4 is 8. 8 times 5 is 40. That's a positive 40 because of the 2 negatives there. Square root of 41 times square root of 41, regular 41. It makes the radical pop off. Okay, those of you that have a weird look on your face because you're not remembering that. When you go like this and square, squaring is the opposite of taking the square root. That dissolves that, and that's why the 41 pops out. Okay, so that is the answer for A. I'll move to paper and do part B. If you don't stop me, I'm going to say that they're all turning out right with respect to the sign and the numbers and all that, because I know some of you are checking them as we go along. Here's part B. Okay, part B is we're doing cosine of 2 theta. Use whichever one of the 3 formulas you like. I'm going to do cosine squared minus sine squared. Okay. Ready to square. I'm going to square on my cosine. This one, it does matter which one you put first or second because you're subtracting. So that matters. But when you're multiplying, it doesn't matter. But try to follow the formulas. Okay, so cosine was, in this picture that I just developed, the cosine was -5, or -4 over square root of 41. -4 over square root of 41. And then the sine was the -5 over square root of 41. Okay, so there's everything dumped in. Square the top as well as the bottom. So top squared, no matter what you square, negative or positive, it always comes out positive. When you square this, it makes the radical come off, and you get a 41. Squaring the top, you get a 25. Squaring the bottom, you get a 41. Pull them together, and there's the answer for part B. C. Okay, so C, we're doing half angle again. Okay, so let's see. We got the plus or minus thing. We already know that what's underneath here is going to be 1 minus cosine of the angle you're cutting in half, and now the 2 is down here. So that way you can use a regular theta off the picture rather than a theta divided by 2. Okay, so the plus or minus thing. Let's go to the restrictions that came with the original problem. It said, let's see, this one said that theta is supposed to be between pi and 3 pi over 2. Let's copy that. Theta is supposed to be between pi and 3 pi over 2. But we really want to know where half a theta is. So cut this in half as well as this and this. This would really be times 1 over 2. That would turn into a times 1 over 2. So 3/4. We need to be between 3/4 and pi over 2. Let's see where that is. Okay, a little picture for this deal right here. Okay, here's pi over 2. This would be 1 pi, so 3/4 is like somewhere right before 1 pi. All right, so don't we have to be in quadrant 2 if we're going to be in between those two things with our half angle? Therefore, when we choose a formula for half angle, in that quadrant, if you're in this quadrant over here with your half angle, see, this says the half angle is between here and here. So what should I choose for sign? Does sign have a positive or a negative sign in that quadrant? Okay, positive. Now let's try this. Good. All right, so we're going to choose that right there. Okay, let's plug in. So sine of theta over 2. Let's go. We're grabbing the numbers from the picture now. So it's 1 minus the cosine. The cosine was -4. -4 over square root of 41. And then down on the bottom there's a 2. So now cleaning up a little bit and trying to simplify this so it looks a tiny bit better, there's a couple issues. Number one, you're going to, well, first of all, you see this turning into just a regular 41? Because why don't we, you know you're not allowed to have a radical down in the bottom like that. So we're going to go square root of 41, square root of 41, making that bottom 41. Therefore, I'm going to change this into 41 over 41. Let's deal with this guy first. So I'm going to do that and that. That's going to turn this into a 41, therefore this should be a 41 over 41. Okay, that's the one there. That bottom has to match that. Okay, let's continue writing this, making it look, it's never going to look great. But here's the top now. You have 41, double negative. Let's clean that up. Clean up as much stuff as you can. You now have 4 square roots of 41 because we just floated that radical up to the top instead of leaving it at the bottom. And both of these denominators, this as well as this is a 41. Still divided yet by 2. Okay, don't forget, you got a double stacked fraction. Take care of that by floating this up to the top with the other fraction and flipping it over. So when you flip the number 2 over, it's 1 over 2. It then becomes multiplication rather than division. But cross this out so you don't use it again accidentally. Okay, now you can't clean up everything, but you can do like little stuff like that, and pull it together. So let's see, what are we going to have now? We're going to have 41 plus 4 square roots of 41 over 82. 2 times 41, 82. Okay, now is there anything that you can take the square root of that goes into 82? 2 goes into 82. 2 times 41. You can't take the square root of 2, you can't take the square root, leave it like that. I mean, if I could have broken that down, that bottom number, and removed something, I would have, but you can't. Check out the answer at the back. Does it look like this, hopefully? Good. Nice. All right. You got to check the answers as we go along. You look bewildered. Did you look for the answer and not find it? Yeah. Oh, okay. I don't want to intrude in your space. Okay, let's go. All right, so cosine of a half angle. All right, so what does that formula end up being? Just instead of a minus as it was right here, it's a plus. So 1 plus cosine of... All right. Now, didn't we do all this just to cut down when you're doing the homework on My Math Lab? We've done all this, haven't we? We just went through all that mess of problems, and we figured out what was inside of here, right? The only difference is that there's a plus in this one and there was a minus in this one. What we do have to decide on is the plus or minus that goes out here, because for that one thing, it'll mark your answer wrong. But at least, why don't we do the inside, and we'll make the decision on the plus or minus in a minute. Okay, so what was the inside? 41. Now there it ended up, it was a plus, right, after all was said and done. So this one's going to be a minus. And I don't know if I need to explain that or not. Please tell me if I don't. But the reason you ended up with a plus here when the formula started with a minus is because, remember, you plugged in a double negative? So what would happen in this one is that you would originally start with a plus, but then you'd go and plug in a negative, and you'd have a plus followed by a negative. You'd still have double signage, but it would be plus minus, and that would end up with that right there, that minus. All right, the plus or minus deal. Did we just not have a discussion about how when you cut the angle in half, you end up over here in quadrant 2? So is the cosine, which we are now doing, cosine of a half angle, we said that the half angle's in quad 2, so does cosine take on a positive or a negative value there? So now we know that we need the negative for the answer here. Okay, again, this is because theta over 2 is in quad 2. I already drew a picture for it up above. And cosine is negative in quad 2. So maybe put that little note so that you understand why we chose the negative. Okay. So what part are we on? Are we done with that one? 3. Oh my God, I don't think I can bear to do another one of those. Okay, let's go to something else. We've already done 2 and 3 that were exactly like, and number 4 is just more of that. So if you want, I can go back and do 4 at the end, but I'm bored with that one. Let's go 5, 6, and 7, because those start to have numbers in them. And you're going to act it out a different way. So let's look at how you handle 5, 6, and 7. We can always go back if you think you're going to need number 4. Okay, here's 5. So 5 is, what is the sine of negative 22.5? 45 degrees. I mean, I think one thing that's kind of pesky, annoying, whatever you want to call it, is the fact that there's a negative in there. I don't need that right now. I really don't need that. So this thing is an odd or an even function, so I know what to do with it. Okay, so if it's odd, I got to carry the negative out to the front. If it was even, I could just erase it. The even functions are cosine and secant. All right, so this one's odd. So just to get this guy out of the way so as not to complicate what is already more complicated than I want it to be, now I go like that. All right, so you know how just about everything that we've done together where you're doing it without the calculator has been based on, when there's an angle there I'm talking about, has been based on either the 30, the 60, or the 45? So we got to get back to them. Somehow we got to drag those guys in here. So when you're doing this and you want to apply half angle, what you got to think to yourself is, which of my old favorites, the 30, the 60, or the 45, could I possibly cut in half to get this guy right here? What angle could you cut in half? 45. So that's what we're going to do. We are going to rewrite the 22.5 as 45 divided by 2, because 45 divided by 2 is 22.5. So you're trying to make use of the angles that we know very well, 30, 60, and 45, but also employ the half angle formula. So this can be rewritten like this. You can leave the negative out front. You can rewrite the 22.5 degree angle as 45 divided by 2. So you have all rights to use a half angle formula because you are cutting an angle in half. That angle just happens to be 45. Let's write the formula that goes with it. Okay, so when you are cutting an angle in half, all right, let's think about this. Okay, so for the sine formula, it is 1 minus cosine. So 1 minus cosine of the angle you're cutting in half. And then instead of the half being underneath the 45, it's now down here. That's what those formulas do. Now we got to pick the plus or minus. So now with this one, it's not as abstract. They're showing you what the original angle is. So think about where 22.5 is. Isn't the 22.5 in quadrant 1? See, you don't have to worry about, oh, where's theta divided by 2, because you actually know what theta is, because they're giving it to you as a number, not just the theta. So this is less abstract than when we were taking the theta and cutting it in half and you were. Here you just put the number and you know where you are. This is the angle already cut in half. So let's see, at 22.5, the sine value would be positive, because you'd be in quadrant 1. So that's in quad 1, where the sine value is positive. Now, you can't help it that there's an extra negative in this problem. That's going to make it turn negative again. But if that wasn't there and we were just trying to pick the plus sign in front of this half angle formula, it is plus because of the angle. Okay, so let's see. If I was picking the plus or the minus, I'm going to write this out just so you understand that there was some double signage here. As far as the formula goes, I chose this guy. But because of the extra negative that the problem developer threw us, that's why there's a minus. Not because I chose the minus as the sign that goes with that formula. Okay, so here we go. Let's plug in. We're basing our answer off of this, and you know how it goes for 45. I need to know what's going on at 45. I don't know that you need me to draw this. Some of you are doing really well with the 45-degree triangle. This represents the sine, the piece that goes up and down. You don't have to worry about x over r, y over r. Just the leg that goes like this, sine. A leg that goes like this is cosine. Whenever your radius is 1. You can use this whole leg for the sine, this whole leg for the cosine. Okay, so plugging in over here. Negative followed by a plus, just a negative. Let's plug into this radical. It's 1 minus the cosine. The cosine is square root of 2 over 2 with a 2 down here. So more of that fuss about getting these things pulled together on the top and then floating and flipping with that bottom number. We're going to go through that part. Okay, so if this is a 2, I want this to be something over 2. If I pull those together, what's inside the radical, it would be 2 minus the square root of 2 over 2. Take this, float it up here, and flip it over. So now it's 2 minus square root of 2. On the bottom, 2 times 2, 4. There's that negative out there. And then you can take the square of that particular denominator. So bring it out as a square root. But the 4 is occurring on the denominator. So when you take it out as a square root, that square root should be in a denominator, just like it's in a denominator inside. So what you're going to take out is 1 over 2. That square root is 2. It belongs in the denominator. Don't forget the negative. Let this trail to the side. Okay, so that's number 5. Okay, 6. Okay, how about we maybe put that in degrees? You want to do that in degrees? Put a 180 for pi and tell me what you get when you go 180. So what is this? This is number 6. Did you get 112.5? Okay, so 112.5. Okay, let's do again, just like the last one. I got that pesky little negative right there. This is also an odd function, so let's bring this out here. I'm not going to leave out any steps in case you need to look at this later, because I don't know how much of this they're going to show if you do view an example. All right, so I don't know anything about a 112. But I do know about 30s, 60s, and 45s, or anything that's related to those. Like, for instance, it's fine if you want to use, any cousin to the 30, the 60, or the 45 is good. We'll be able to handle it. Like, for instance, 150. If you rotate to 150, don't you have a 30-degree reference angle? Therefore, 150 is related to 30 degrees. You're going to be basing everything off a 30-degree triangle. So remember, there are cousins to 30, 60, and 45 that are good as gold. Okay, first of all, to figure out what you have to cut in half, like I just did the last problem, I had 22.5, right? That would be the number that you have to cut in half to get right back to what you're seeing here. So whenever you want to know, hey, what do I cut in half to get this? Just double it. So that doubled would be 224, 225? Okay, we're going to cut 225 in half. I guarantee you 225 is related to either 30, 60, or 45. Okay, so we are going to rewrite this as 225 divided by 2. And because I am cutting an angle in half, that gives me the right to use the half angle formula. And again, all I did was double that number to get this. This would be the thing that you cut in half to get right back to that. Cutting in half and doubling they go hand in hand. Okay, so let's see, what's the formula for that? Let's go to our formula sheet. We have 3 different formulas, and I am definitely not feeling the one with the radical wrapped around it, because then I got to make a decision about the plus or minus. So on that one, choose one of the other ones. I think I'm going to just use the one with the sign on top. Memorize one of them, whichever one you think you can stick in your head better. So this is going to be sine. So it goes like this. Tan of some angle that you're cutting in half, and then over here it's tan of that angle. Sine of that angle, and then it's 1 plus cosine of that angle. That's what that formula says. Okay, I'll write it right here just so you can look at what I'm using. Tan of any angle cut in half, our angle's at 225, is equal to sine of that angle that you cut in half over 1 plus cosine of the angle that you cut in half. This is what it looks like on the formula sheet. This is what it looks like with numbers plugged in. Okay, here we go. We need a picture at 225. So roll to 225. That's going to be 180 plus an additional 45. That'll get me to 225. I just spun 45 degrees past the 180 mark to get here. That gets me in a triangle with a 45-degree reference angle, and therefore both legs are square root of 2 over 2. This one as well as this one. But because of the quadrant that you're in, they are both negative. Now go back to the back to the problem, and start plugging in the values from the picture. Now in this case, just the leg that goes like this, cosine. Leg that goes like this, sine. You don't need to do y over r because the r is 1. This is the cosine. This is the sine. I don't know if you need me to point that out anymore at this point, but maybe yes. Okay, so sine was square root of 2 over 2, negative. And then it's 1 plus cosine of 225, which was also negative square root of 2 over 2. Now I'm done choosing the formula. I'm done plugging in. It's all arithmetic from there, trying to make it look like semi-better. Okay, so let's see. I'm going to write this as 2 over 2. See if I can make the bottom look better. And then I'll do the float and flip thing in a minute. All right, so pulling those together would be 2. Double signage right here. A plus combined with a minus, regardless of which one happens first or second, is a minus. It's 2 minus square root of 2 all over the same denominator. Since I have a double stacked fraction, I'm going to try and turn it from 3 fractions into just 1 fraction. See, there's 1 fraction, 2 fractions, 3 fractions. So to get less fractions, I'm going to float and flip. Okay, bring this up here, right alongside the top fraction. So in turning it from division to multiplication, you have to flip the divisor. So now it's going to be 2 on the top with 2 minus square root of 2. Now you know I'm doing tan. Tan's always more complicated. It's always going to have more steps in it, just like in the last section. So I'm not looking at this anymore because it's now at the top. The 2's cancel. And what you're left with is this. All right, we had negative square root of 2. And let me make sure that all of this is right. Yes. Okay, good. All right, so then we had this left over. Negative square root of 2 at the top. Nothing else is left there because that's gone. It just canceled with that. And at the bottom, we have 2 minus square root of 2. What do you think I still have to do? Get the radical out of the bottom. You're not allowed to have radicals in the bottom. Okay, so now that if this wasn't here, and all you were trying to do is get rid of that, you would just go square root of 2. Another number by way of a plus or a minus, you got to use conjugates. So the conjugate of this is this expression all over again, but with a different sign in front of the radical. You always switch the sign in front of the radical because sometimes you know that the radical might be up here and you might be thinking, oh, I always switch the thing in the middle. It's not the thing in the middle. It's the thing that's the sign that's in front of the radical. So if you chose to multiply by this as a conjugate, you must do the same thing at the top. So in essence, you're putting the radical that was in the bottom to the top. All right, little shortcut. Let's go over these shortcuts every time we get a chance. When multiplying conjugates, you're about to FOIL this, right? That would mean you going this times this, this times this, this times this, and this times that. I'm trying to get you not to do that anymore. I want you to go, every time you see conjugates, square minus square. It'll cut down on 4 of the steps, because this is really 5 steps to get that done. So either be looking here or here, doesn't matter. I want you to square the front, square the back, and then throw a minus in there, and you'll have it all FOILed out. Okay, so squaring the front, 4. Squaring the back, 2. Because when you square a square root, it just makes the radical pop out, dissolve, and then out comes the radicand. And then put a minus in between these two squares. Your bottom turns out to be 2. Okay, the top. The top you're going to distribute. So it's 2 times square root of 2 with a negative. I'll do it here. 2 times square root of 2 with a negative. And then square root of 2 times square root of 2, 2. But there is a negative. Okay, and one more step to complete the annoyance. What number goes into every single one of these coefficients? This, this, and this. Or might I say, all the numbers, what number goes into all the numbers that are not underneath a radical? 2. So you're going to go this divided by 2, this divided, you have to have, if you are going to reduce at this point, you have to be able to come up with a number that divides into that, that, and that. Okay, so final answer, this divided by 2 is -1 in front of that square root of 2. This becomes a 1, and the bottom is a 1. That's your final answer. So I don't know if I can stress this enough to you. If you try to do this problem with a calculator, look at all the stuff that you get to cut out. You can prove to me that you know nothing about trig. You don't have to do that, any of the algebra. You would go straight into a decimal. That's why I'm trying to explain to you why I can't accept those answers, not even for 1 point. Okay, so make sure that you are not using it for anything unless the problem says, I'll tell you again, if it says approximate, you may use the calculator. If it says round, you can use the calculator. If it flat out says use the calculator, you can use the calculator. But otherwise, don't do it. What number are we on? Let's see. We are on, hopefully that answer was right. Did someone check it? Did we lose a negative somewhere? I got a feeling we did. Yep, we did. All right, I can fix that. Come right back here. Let me tell you where that happened. Ooh, let's make it real small. Remember at the beginning of the problem how we scooped the negative out of there and brought it out front? I didn't drag it all the way down. I jumped right into what is the formula for this, and which was this, all the way down. So that extra negative, bring it all the way down. Specifically, why don't you just bring it down to the last step that we're on? But anyway, I don't know, you could circle it if you want. Go all the way down. There was that extra negative. All the way down. Specifically, we're going to look at what it does to this answer right here. Hopefully it fixes it. So it's negative times everything that I got. Because when there's a negative out in front, you can apply it at the end. So let's see, that would turn the square root of 2 into a positive square root of 2. And it would turn the -1 into a positive 1. Is that the answer? Thank God. Okay, good. Move on. And then tomorrow, when you take the test on Thursday, you try not to do that. Okay, so let's see. What else? We got, so we did one like that, one like that. Let's do, okay, let's go to 7. 7, 7, 7. I don't want to leave you with too much of this undone because you need to get this homework done like pronto. 67.5. Okay, let's see if you can think of more on your own this time. What angle, and if you don't call it the right thing, no shame. We're just trying to think here. What angle do I have to cut in half to create a 67.5 degree angle? 135? Okay, so you just double it. I think we all get that at this point. So cosine of 135 Okay, so as far as the formula goes like this, that up underneath the radical is 1 plus cosine of the angle that you're cutting in half, the 135. See, by the time you get underneath this, you start expanding in the formula, you should be using only angles like 45 or things that are related to them. 135 is a cousin to the 45. Because when you move to 135, you're going to have a 45-degree reference angle. So this is related to one of those. And then the 2's down here. And then I believe we need to choose the plus or the minus. Only you don't have to think about theta over 2. This is the theta over 2. So when you're at 67.5, isn't that in quad 1? And isn't cosine positive in that quadrant? So I'll choose positive. Okay, here we go. Let's go to 135, just so you have a visual on what I'm doing rather than me just calling it out. Okay, I just spun to 135. There is 135. The reason that I know that this is 45 degrees is because right here is 180. That is a landmark that allows me to figure out what the reference angle is. See, 135 plus 45 will get you to 180. That means this leg is square root of 2 over 2. This leg is square root of 2 over 2, although this one's negative. This guy, the horizontal leg, always represents the cosine, which we need. This represents the sine, but we won't be using it. So now come over here, plugging into this. Okay, so cosine is that negative square root of 2 over 2. Divided by 2. Let's clean this up. We'll call this 2 over 2. And we've got some double signage here. So it would be 2 plus combined with a minus is a minus. 2 minus square root of 2, both over 2. Divided again by a 2. So this just floats up here, becomes a 1/2 rather than a 2. And now it's multiplication. That's not there anymore. So now this would be 2 minus square root of 2. 2 times 2, 4, all up underneath that square root. The thing that you can take the square root of is the bottom. What? Yeah, but it's not based on... Ooh, wait a minute. Let me think. I might have just told you the wrong thing. Let me look at that. No, you're supposed to be going by the angle that's been the half angle, which is that 67.5. What's the answer in the back? You're making me doubt myself. It's positive, isn't it? Yeah. Okay, because if I go with what you're saying, you're going to get a negative. It's based on this. Like when I just did this last problem, that was, well, I've done 3 of these. This is my 3rd one. This is the 3rd problem where I cut an actual number in half, right? So when you're doing it like that, what you have to consider is that original angle. The original angle is what you're using to choose the sign. So do you get that 67 is in quad 1, which is why I put the positive there. All right. So anyway, I was saying to take the square root of that, so 2 minus square root of 2 over 2. Now you can go right by these examples that I gave you and all the work that I showed you as you do the homework, because they're going to mimic these same problems. I grabbed them from my math lab. Let's go to the next one, which is number 8. See if I can get through all of them. I don't know if I can. Okay, let's turn that into degrees, that 5 pi over 12. They're throwing you a lot of negatives today. So 5 times 180 divided by 12, 75? Now this is going to be... All right, so I'm going to bring this out here because this is odd. I got to remember to drag that negative in as I go along. So anyway, if somebody is telling you to show that you know how to use the half angle, what half angle would you be using for this particular problem? Okay, what angle would you cut in half to get 75? 150. 150. Now let's think ahead about how the answer should look before we get into all this algebra mess. Okay, what's the formula for this one? Doesn't the formula go that when you're doing this half angle one, that it goes 1 minus cosine of the angle that we're going to cut in half? I guess I should write that here, because we're going to predict what the sine should be on the answer. So this would be sine. You said that what I should cut in half is 150 to create a 75. Okay, so that's important to know, because when you go to expand the formula underneath the radical, that angle that you decided to cut in half is what appears over and over again underneath the radical. That's why you got to think about this first and then jump in here and start. We are going to pick the plus or the minus. All right, so we got a choice of plus or minus here. So what I was saying is that if you're at 75, wouldn't the cosine be positive? But then there's that extra negative, right? The answer, there should be a negative in the final answer. Go check the answer key. I know we haven't done the arithmetic yet. Is there a minus out there? Okay, so we're good about that? That whatever that, if it's a numeric number that they're giving you, that is the half angle. So at that half angle position, the cosine is positive. The only reason you're seeing a negative answer is because of this extra negative that they threw at you right there. Okay, so here we go. We said that we're going to use what? This guy? No. We said we're going to use the positive there. So let me be very specific here. I'm using a positive while expanding. However, I got thrown an extra negative. Here we go, plugging in. At 150, I don't know if you can do things in your head yet, probably not. So let me actually give you a visual. At 150, you have a 30-degree reference angle. Any triangle that's 30, 60, or 45, you have the ability to put the numbers on the legs, and the legs are the cosine and sine. So across from the 30 is always the short leg. Across from the 60, which would be up here, would be the long leg, which does happen to be negative. And from this picture, you are able to tell what sine and cosine is so that you can use it on whatever formula you want to use it on. I only happen to need the cosine. Okay, so it's 1 minus, the cosine is this right here, negative square root of 3 over 2. This minus is from the formula. So let's see, I'm going to go like this. I'm going to say that that is a positive, that double negative. I'm going to call this 2 over 2. Let's see, what I got in here is 2 plus square root of 3 over 2, and then over 2 again. I'm going to float and flip that 2. Don't look at that anymore. So now it's 2 plus square root of 3, blah, 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 over what, 4? All of that underneath the radical. Don't forget to keep dropping that negative down. Okay, and then you could actually take the square root of that, which is going to be 2, but it's in the denominator, so it comes out like this. Square root of 2 is 2. That 2 is in the bottom with the negative right there. And then this, all of this radical. Okay. Whoa, okay, let's see. 9. Are you still copying that? Okay, this one says solve the equation. Need clean paper to concentrate. Okay, 9. Okay, here we go. We're practicing section 7.3 right now. So What is not cool about this problem is that it's got two different trig words in it. You know, you're not going to be able to solve while you got two different trig words. So I'm going to get rid of cosine of 2 theta by trying. See, here's where it's kind of good if you knew the alternative versions of cosine of double theta. Weren't there three different formulas for it? I would like to make this problem so that we're talking all sine. Sine everywhere, not cosine. I definitely don't want that. And look at the choices that you had for cosine of a double angle. See, if it comes to a problem like this, maybe I can help you out if it calls for alternative versions. So why don't we agree to this? Why don't we agree that for this cosine of a double angle that you're going to memorize this one? If it does turn out that you get thrown a problem like the one I'm doing right now, and it would be in your best interest to use one of the alternative versions, I'll give it to you. Your head is going to be too stuffed already. What else had multiple versions? Which one you like best here for tan? What looks easiest on the eye for this tan deal? This one? I like that one too. So let's everybody memorize that one. If it turns out you need that one or that one, I'll give it to you. Okay? I don't think you will though. All right, so anyway, what I was saying is I want to get rid of this guy. I want to go all sine here. So let's see, what's this one has nothing but sine in it. See that version right there of the double angle? I'm going to use 1 minus 2 sine squared. 1 minus 2 sine squared. 1 minus 2 sine squared, and then whatever angle is being used here, you use that same angle. So I just did substitution. I substituted the complicated part out of the problem, that being that there was too many different trig words. So now I have one trig word. Leave what I have here now. This and this are like terms, so I can combine them. And that's even better, because now I can put that together with that. So I would now have 1 plus 6 of these. Then I'm thinking, okay, second degree, don't I have to get the squared term by itself or else factor? When you're solving second degree, you can either bring everything to one side and factor, or I did give you one of these, a couple of them actually in section 7.3, that if you don't have a linear term, do you see that there's no sine to the first degree? And when you only have a second degree and a constant, you can use square root property. That calls for isolating the squared term while getting all the constants on the other side. So it's a non-factoring approach to solving second degree. This would be -1. This would be 3. Completely isolate that sine squared term. So reviewing how to solve an equation. Make the square go away by taking the square root of both sides. That's going to give you plus or minus 1/2. Let's try and make that plus or minus square root of 1/2 look like something we recognize. That is really square root of 2 over 2. Because look, if you went like this, it would be what? Square root of 1 is 1. And then square root of 2. Square root of the top is this. Square root of the bottom is that. And then if I made it look like what you're used to seeing, couldn't I just rationalize this and go like that? To get an equivalent form, so that would make it look like what you're used to seeing, and then possibly you would recognize that the reference angle we're looking for that would make that kind of number happen is 45 degrees. Reference angle has to be 45 degrees. So let's review with you how to get all the answers here. Okay, let's see how many of you are on top of this. How many answers do you think they are? Forget about whether you know what they are. Just are good. Okay, the sine's the y value, right? But this says that the sign can be positive or negative. So they're positive up here in quadrant 1 and 2, and they're negative down here. You can have triangles in all 4 quadrants. We want to figure out where the hypotenuse of each triangle is, because those are the answers. So reference angle has to be 45 here. And really, if I was you, all you really need, if you already know what the reference angle is, you don't need to draw the whole triangle. You just need to squeeze in that reference angle. And then tell me where the spinning arm is. I don't care if you close this up. That's not going to do anything for you. Tell me where this is. This one's at how many degrees? 45 or pi over 4 like they love you to answer. This one, how many degrees is that one? It's either 135, or if you're trying to answer in pi form, think of this as pi over 4. So that would have to be 3 pi over 4. Again, for the people that still look cross-eyed when I do that. This is the same thing as 1 pi, which is 4/4. You stop 1/4 before you got to 4/4, so you're at 3/4. That's 2 of the answers. So being that that's the case, 4/4 plus an extra 4th, and then that last one, 7/4. You guys are awesome. Okay, last one. We're going to work the middle out. So it's number 10. There's a sign on the outside, 2 inverse cosine. This will be a review of section 7.4. No, 7.1 I guess it was. 7.1 with all that inverse stuff. Okay, so as soon as you see inverse, you got to start remembering restrictions. Remember the sunrise? That was the cosine restriction. That's how you remember the restriction, right in there for inverse cosine. And that's the first thing you should write. So now what, and you also have to remember this, that an inverse is an angle. So all of this mess that you're seeing right in here is not all of it, that part right there. You want to figure out what that is. Okay, n inverse is equal to an unknown angle. You can rewrite it, maybe so that it makes more sense to you. Okay, so all I want to know is I want to know what this inverse is equal to. I'll drag the 2 in there in a minute. Okay, so let's see. So now I wrote that it's equal to some unknown angle. I switched these two because that's how you go from inverse to non-inverse, if you remember this. Now tell me, what angle does this have to be for you to get a cosine or a sine value of square root of 2 over 2? 45 degrees. You guys are getting good. Okay, so this angle would have, now, aren't you, if you want the cosine to be positive, don't you have to be over here? So we're just going to say that, because over there it's negative. We don't want that. So we're just going to say we're shooting for just this angle right here, 45 degrees. That keeps you in quadrant 1 so that you have a positive square root of 2 over 2 for your cosine value. I don't know what in the heck I have here. What is this? Get rid of that. Okay. We want to stay right in there. All right. So now, ready? I'm going to come back in here. Get back up in here. And if you want to keep this, maybe you might want to keep this as, no, never mind. All right, here we go. Back to the original problem. So sine of 2 times the theta that this is equal to. 2 times the theta that this is equal to. My mind's gone blank.